Welcome back to our dialogue about the law of sines, and in this video we're going to talk a little bit about really what's an extension of the law of sines, which is using a new formula to find the area of an oblique triangle. Let's jump in. So let's go back in time a little bit to when we were in elementary school. Perhaps you remember that you were taught how to find the area of a triangle. Back maybe fourth grade or fifth grade, you were given a very elementary formula in order to find the area, but you had to have two key pieces of information. And you would have been taught that the area of the triangle is found by, the area of the triangle would be found by 1/2 times the base of the triangle times the height of the triangle. And the height of the triangle would be defined to be an altitude of the triangle. So it would form a right angle with another side or an extension of a side of a triangle. And that other side that it forms the right angle with would be denoted as the base. Often the base is the bottom of the triangle, but it is really defined to be the side that the altitude makes the right angle with. Okay, well, let's recall some of what we learned in our discussion of law of sines. We learned that we could find the height of a triangle by taking an adjacent side and multiplying it by the sine of a given angle. So if we knew the measurement of angle A, we could take the sine of angle A and multiply it by B, and that would actually give us the height. If we were looking at this particular triangle, which side would represent the base of our triangle? Hopefully you would say, and I gave you a hint by colors, that side C is going to be the base because it makes the right angle with the height. Okay, so if we take our initial formula and adjust it with these definitions, we end up with a new formula, okay? So we can say that area is equal to the half of the base times the height. Let's replace the base with side C, which we just determined to be the base of this triangle, and let's replace H with what we determined H to be, which is B sine A. So we end up with 1/2 times C times B sine A. And normally we write this as the area can be found by 1/2 BC times the sine of A. Well, what if I know other sides in a different angle than angle A? Well, we can also find the other two variations. Notice that the side lengths here are angles that are not the same letter as the angle that we're given. So we could also write those in two different ways. We could say 1/2 times the measures of side A and C times the sine of angle B, or we could also say that's the same as 1/2 times AB times the sine of angle C. Notice in all three cases we have side lengths for two angles, and we are given the measure of the angle that's between them, right? Because the angle opposite side A would be angle A, and the angle opposite side B would be angle B. The angle between those two would have to be angle C. All right. So let's take a look at an example. So here's an example of an area of a triangle problem. Let's say we have a triangle that we know two side lengths in this triangle. We know that one of the side lengths measures 8 meters, one of the side lengths measures 12 meters, and we know that the included angle is 135 degrees. Well, since we have two sides and the included angle, we are in luck because all we have to do then is substitute those things into our formula. The area of that triangle is going to equal 1/2 times the length of side B times the length of side C times the sine of angle A. And we don't have to actually assign those things. We just know that we've got 2 side lengths and the included angle, so we can just substitute things in. So if I simplify the trig part of this, sine of 135 degrees we know to be square root of 2 over 2. And then if I crunch these numbers, if I take half of 8, that's 4, and 4 times 12 is 48, and half of 48 is 24. I'd get 24 times the square root of 2 square meters. And then our calculator would be able to give us a decimal approximation of about 33.9 square meters. Both of these representations of area are valuable. One is precise, and the other we relate to a little bit better, right? 24 square root of 2, we don't really know what that means, but when we look at the decimal approximation, you say, oh, well, that means that it's about 34 square meters, right? So knowing how to find both of those is valuable. All right, then we have one more example of this, and this would be this example. Find the area of a triangle that has 2 angles with measures of 40 degrees and 52 degrees, and the included side is 18 inches in length. Round to the nearest tenth of a unit. Okay, so here we have different information, and it's not exactly what we need to use that formula. So let's pick this apart a little bit. Let's start by assigning labels to the angles and side lengths. Okay, let's say that angle A is 40 degrees, angle B is 52 degrees, and that means the included side that's between angle A and angle B would be side C, and that'd be 18 inches. Okay, so I've got 2 angles and a side length. Remember that in this formula, I have 2 side lengths and the included angle. Okay, so I can use either angle A or angle B, but either way, I'm going to need another side length. Okay, I'm going to need either side B or side A to use one of these formulas. Okay, so first let's go ahead and find the remaining angle measure. We know that the measure of angle C plus 40 degrees plus 52 degrees will equal 180 degrees, which means the measure of angle C will equal 88 degrees. Okay, so now I have all 3 angle measures. Now I just need one more side length in order to use this formula. Okay, and I needed this angle measure to apply law of sines. So let's apply law of sines and solve for side length B. I know side C is 18 inches. I know that that divided by the sine of 88 degrees will equal side B, the length of side B, divided by the sine of 52 degrees. All right, and then as we've done before, we're just going to cross multiply. B times the sine of 88 degrees will equal 18 times the sine of 52 degrees, divide out the sine of 88 degrees, and then crunch in our calculator. So we get B is about 14.19 inches. All right, so now I have side C and side B, so I can go ahead and use this formula with the sine of angle A, substitute all the appropriate things in the right places, and then use our calculator to crunch these values. All right, so half of 14.19 times 18 times the sine of 40 degrees is going to give us about 82.1 square inches. Always look to see what your problem asks you to round to. And in this case, we've got it rounding to the nearest tenth of a unit. All right, see you next time.